Welcome everyone. Today we are looking at how GitHub Copilot agents manage memory and state and how we measure whether they are doing a good job. Now everybody would be using one of the AI agents, and when if you have experienced it, you know that as AI agents take on longer multi-step coding tasks, they need to remember context, what the goal is, what has been done, what is next. This learning module from Microsoft, the link is provided below, covers three interconnected ideas. First one is how memory works. Second is short term versus long term, how state is persisted across sessions using GitHub itself, and how we enforce quality through evaluation gates. By the end, you shall understand why simply giving an agent a task is not enough. You need to set up the right memory and quality structures around it. All right, now let's look at what are the agent memory strategies we should apply. So first thing, an agent's effectiveness depends on what it knows at any given moment. Three, three memory layers matter here. So as you can see in the slide, first one is short-term memory. So short-term memory, you can think of it as like a RAM of a computer. It holds the current task context, whatever you have asked it to do, whatever the recent instructions you have given, and the next actions. It does not survive session boundaries. So one session after another, this memory does not survive. Then the second is long-term memory. It is a curated knowledge reused across tasks, summarized decisions, patterns, structured facts. Stable, but it needs intentional management. So, and the third form of memory is external memory, which is the most important for GitHub workflows. Now, GitHub itself manages this in forms of issues, the issues which you create, where you provide descriptions on what the acceptance criteria is, etc. The pull requests, which is generated to achieve that goal of the issue. The commits, which the code changes which you are making, and it is being committed, and the workflow runs. So these are stored as persistent memory and which is visible to the whole team. So what is the key rule here? Do not flood the context with irrelevant information. If you, the saying says that garbage in, garbage out. So if you provide lots of irrelevant information, then the output will be bad. So you should not flood context with irrelevant information. It causes stale or confused agent discussions. Now let's move on to the next topic. So now let's talk about how GitHub manages it as in form of persistent state and managed context drift. So when tasks span multiple sessions, the agent need to resume without repeating work already done. So you don't want to waste your tokens in redoing the same thing. Now GitHub acts as the state machine. Issues define requirements and acceptance criteria. PRs track the active plan and code changes. Commits capture every incremental step, and workflow results show what has happened, what has been validated. So the 5-step resume flow shows how an agent picks up after any interruption. One is open the PR, then read the description, review commits, check continuous integration results, CI results, and then continue from the latest state. Now you have to watch out for context drift. When agent actions no longer align with the original goal, signs include PR changes that miss acceptance criteria, commits that contradict decisions, or failing CI checks nobody acted on. If you detect drift, stop the agent, re-anchor to the issue definition, and provide explicit corrective instructions before continuing. Now let's talk about evaluation signals and quality gates in Microsoft GitHub Copilot. So evaluation is how we verify the agent did what was actually asked. And it is not optional. It is the contract between agent output and the code base. It consists of 7-step flow, which is the full life cycle of the evaluation. 1. You have to create an issue which defines the task. Number 2, agent opens a PR. Number 3, GitHub actions trigger automatically. So that is the workflow step. Then status checks surface on PR. Number 4. And number 5th is required checks, which you have made mandatory. They must all pass. Number 6 is a reviewer approves, then merge happens. Then you can see that each step is a get. And required status checks are the backbone. Branch protection rules prevent any merge unless all workflow checks are green. The agent cannot bypass this. On top of it, we have security scanning, which adds another automated layer. Code scanning, dependency review, and secret scanning block unsafe changes without any manual intervention needed. Now, review requirements keep a human in the loop. At least one approval alongside passing checks ensure final judgment stays with a person, not with the agent. So as you can see, that GitHub Copilot workflow is intended to keep agents safe and productive. Please share your comments on how do you like this talk. Thank you.